All right, so with that, why don't we move on to our next presentation? As we promised earlier, this is a presentation on the basic formal ontology, which underlines and underpins the Allotrope Foundation ontologies. And this will be presented by Amnon Potashik, who's Allotrope's technical director.
Hi, do you hear my voice?
Perfect. We see the slides and we can hear you, Amnon. Go right ahead.
Yeah, I'll check. Okay. Thank you very much. Next presentation, I'll discuss how AFO leverages the BFO, the Basic Formal Ontology, to achieve data interoperability. We will start with BFO Primer, which is based on a lecture note from Barry Smith, the inventor of BFO. So large organizations are complicated. Most data is modeled in relational models and stored in tables in relational databases between R&D, IT, accounting, and to extract meaningful information, you need to query data across tables, domains, resolve tables to join. You cannot query those tables without deep knowledge of the tables and the relationships. So there is no common and universal vocabulary, and navigation between the different information systems can become very complex. So I'm having problem with the mouse. So this is where ontology can come to the rescue. So if we want to run some business transaction between the different type of organization or in between the organization, we can, for example, utilize the FIBO, the financial industry business ontology, which provide a global financial vocabulary to the transaction. So the ontology provides a control way by giving a control vocabulary to organize knowledge. So what is exactly an ontology? Is it a computable lexicon? Is it a dictionary that can be used by both computers and human beings? Let's settle down from now that it is a representation of type of entities in a given domain. Again, type of entities in a given domain and the relation between them. So ontology, they are promoting interoperability across heterogeneous data system, and they provide stability. They provide stability by exploring the relative stability of our own natural language, English. And it is extendable. We can easily extend a phone to a smartphone. So the over-foundry strategy for promoting ontologies was the hub and spokes, where BFO is the hub at the top of it's a top-level ontology, and it extended from the spokes immediately after the BFO into mid-level ontology, domain ontology. So why BFO? It is small, very modular, evolves carefully, and something that is very careful design. It is a domain neutral top ontology, and we'll see it in a moment. So here we see the modularity that achieved both vertically and horizontally by the OBO foundry. It reduces the need for mapping, and horizontally we are getting top-level ontology as the BFO, the mid-level ontology with commons to many subsets of domain-level ontologies, such as the IAO, the Information Artifact Ontology, and we have domain-level ontologies such as the sequence ontology, cell ontology, and AFO adds a set of domains such as calibration, injection, pumping, and so on. So BFO evolved into an ISO standard, 21838, just the mid of last year, and the top-level ontology was defined that this is an ontology to provide a representation of categories. Categories are general classes or type that can be shared across many domains, and it is represented by a domain neutral terms. So we have here the top level ontology, the BFO, and we have all the different categories that are shared across many domains, as well as AFO domains that we'll see in a moment. So now that we have an understanding of the motivation behind the BFO, we can start talking about how AFO leverages the BFO and the alignment between the two. Through this following slide, I will use a screenshot from a BioPortal, which is an ontology lookup service, both for AFO and BFO. BFO is at the top. How the web ontology places things at the top. So practically, entity is at the top of the hierarchy, and practically everything around us is an entity. So if we look at the screenshot for the AFO, we see entity at the top of the tree. Now entities are divided into two disjoint categories, continued and occurrent. Continued entities exist through time, occurrent exist in time. Again, the first one, continued entities exist through time, the occurrent exist in time. The continued have continuous existence in time, can gain and lose parts and preserve their identity through change. They still have the same identity. While the occurrent have temporal parts, they unfold themselves phase by phase, and they exist only in their phases or the different stages. And we see the AFO entity and then splitting into continued and occurrent. So let's have a more understanding of those terms. A continued is something that exists at an instance in time and continues to exist through time. Example, a machine, a bolt, a factory, a tool, a letter, the smell of coffee, smile, handyman. At any time when a continued exists, so do its parts. So a bolt is part of a machine, and it preserves the identity through time. So if we look at the now at the occurrent, as opposed to continued, it's something that has temporal parts, an experiment, tools, smiling, drinking coffee, fixing, sending a letter, events that occur at an instant of a time and processes that last through time are both occurrent. So both event and process start, and we'll see it in the ontology. So here we see the AFO, and we have entity occurrent that it now has a subtype of event and process boundary that are part of the terms are process start. In reality, process and things exist in different ways, and so we should keep the ontology. It can be either a oil pan, which is a continued, or pumping, which is an occurrent. You can't have it both. Either it's the object itself or the process. So there are completely two orthogonal and complementary perspectives in many areas. Commodities versus services, car versus car rental. Commodity is a thing, car rental is a process. So continued can participate in occurrent. So when handyman, which is a continued, can participate in occurrent, which is tools gathering. And the same goes for rental, which is a process. So the actual top three most general universals that we are getting from BFO is independent continued, dependent continued, and the occurrent. So let's start and try to understand the independent continued first. Example, a CPU is part of a computer, but it can be detached from the computer and still exist. This is different from dependent continued. For example, a smile, you can't detach a smile from your face, or the red color at the center of a watermelon. You can't have it without the watermelon itself. Independent continued is an entity that can exist by itself, or possibly it is a physical part of another entity, a machine, the bolt, a factory, a face is part of your body, so it's an independent continuum. While a dependent continuum can only exist in relation to another object. It means that dependent continuum exists by virtue of another entity, and it is not part of the entity, such as the color of flower or a smile. And if we are now looking at the AFO, we see those three top categories. We see the entity, continuum, divided into independent continuum and dependent continuum and occurrent. AFO adds a category to express general roles at the top in context of data or people. So we see here the general roles in context of data, input role, data input role, physical input role, and output role, and with regard to in context of people, analyst role, approval, controller role, and so on. And they are all under continuum. AFO adds also category for information content entity. So things that are related to data cube, data set, facets, nodes, proposition, and so on. Now let's drill down into occurrent. Occurrent can be a process entity, it can be process boundary entity, spatio-temporal region entity, and temporal region entity. We will focus on process and process boundary. A process is something that happens over time. It has temporal parts and it depends on a continuum. For example, your life. Your life has several parts such as infancy, childhood, and so on. And it involves a continuum, which is you. A trip, writing a letter, sample preparation in a lab, they are all processes. And if we look at the AFO, the tree of the AFO, we can see, for example, a process, a chemical reaction, ionization, electron ionization as part of the process tree. And the process boundary, this is simple, is the process boundary is the instant temporal boundary of a process. For example, first time eye-opening of a newborn baby, leaving home to start a trip. So if we look at the AFO, the process boundary has achievement, arrival, departure, mission, reception, end, and start. Now let's drill down into dependent continuum. Dependent continuum is either a quality, which is non-realizable, and we'll touch it in a moment, or a realization of a role, a disposition, or a function. So looking at the dictionary, realizable is able to be achieved or made to happen. With a realizable entity, values does not need to exist, and the existence can change over time. Again, value does not need to exist, and the existence can change over time. So all those realizable entities, for example, a screwdriver function realized by turning a screw. Quality is not realizable. You just have temperature. Even it may change over time, you just have the temperature. So quality is something that objects of particular type have for the entire time they exist. Example, the mass of a bag of tea, the shape of an umbrella, the fragility of a glass. Although it may change, a bag of tea has a mass and the umbrella always has a shape. So let's look at the AFO. And in the AFO, we see entity, continuum, dependent continuum, quality. So we see acoustic quality, conductivity, and for example, electron energy. And now let's move into a realizable entity, such as role. Role specifies the goal that is not necessary to the object design, but can evolve. For example, the role of being a librarian, the role of delivering books, the role of a shelf to store books, the role of a bacteria in causing an infection. And let's look at the AFO. The AFO, we see quality, realizable entity, role. So we see agent role, analyst role, and we see even material, coded material role. We'll skip the disposition, we'll go into function. Function is a disposition that is a purpose of an object, either through evolution or by design. Example, the function of glass may be to hold drink, the function of the heart to pump blood. Let's look at the AFO. We see the function, and the function is under realizable entity, and down the tree to convert, to transmit data, to count cells. And last, let's talk a little bit about independent continuum that can be material entity or immaterial entity. So let's focus on material entity. As you can see, independent continuum is divided into immaterial entity and material entity. So material entity has some matter as a part. Matter is intended to encompass both mass and energy. It includes energy. Material entity can move or localize in space, example, a fish, a soccer team, a sea wave, the energy wave. And if we look at the AFO, we can see it, for example, split inlet, which is a subtype of a gas chromatograph inlet, which is a subtype of an artificial system, a system which is subtype of material entity. And as for the energy, we can see material entity, energy, electrical energy. Altogether, we review some of the categories of the BFO. BFO is small, only 35 terms, 5 levels, and all the relation is a subtype of. So occurrent is a subtype of entity, and process is a subtype of occurrent, and a role is a subtype of dependent continuum. So now that we are already expert on BFO, we can start building ontologies with BFO. BFO is based on realism. Ontologies are representative of reality. That means that when you build an ontology, you should look at things in the world that the ontology is supposed to be about. You should know what those things are like. For example, you can view a fulfillment center as collection of goods, stocks perspective, or as a distribution of goods, flows perspective, stocks versus flow. Ontologies are representation of universal in reality. Universals are general expression, describe all kinds of things that the ontology represent, type, category, species, and it has instances. For example, Europe is an instance of continent. A continent is a universal. Europe is just an instant and not a universal. The same goes with a catalog. A catalog is a kind of things. It's a universal it's a category in the warehouse, while the inventory is a list of instances of the kind of things in a given point of time. That's the instance. When you use scientific ontologies, they consist of general terms, and general terms can be used to formulate scientific laws or design scientific experiments. When you're performing a scientific experiment, you are mostly interested in instances, actual instances. But when you are trying to convey the scientific theory about this is about general and universal, so you are using the universal and the terms to set up those theory. So to develop a new medication, you need both. You need the kind of patient, for example, hypertension patient, this is the universal, this is the general, and the patient themselves, those are your instances. And the BFO has taxonomy traffic rules. First of all, every term should have exactly one parent, single inheritance is a, and there is a two-part definition, which is, I'll go directly to the example. Human being is an animal which is rational, and rational is the difference. B, human being, is an animal, which is C. C is specific to the difference, which is rational. That's the difference. And let's look in the ontology. So, for example, we have material, and if you remember, material is an independent continuum, and under the material we have object and object aggregate. So, object is a material which is single, and that's what differentiates from the object aggregate. So now that we understand how to construct the AFO, let's look at our Allotrope foundation ontology, all the composition and the components. So let's start with data and semantics. We are using vocabulary to describe data. The AFO vocabulary contains classes, relations, and annotation. And we'll do an example. We will model an instance of a computer with a CPU operating at a clock speed of 3.5 GHz. So in a simple graph model, there are two nodes represented here, the computer and the CPU. Each node has its own universal unique identifier and connection between them. In addition, we have a quality that is related, a dependent continuum, related to the CPU. As you see it, this is a minimal graph with some information, but using the vocabulary, we can get semantics about the node and the connection. So we'll start with a semantic about the classes. So we have a node to represent the computer. So the computer is a device, which is an artifact, material, and it is an independent continuum under entity. And we have the same as a device, we have a CPU. The reason that it's not in the screenshot that we don't have the term yet of a CPU. And for quality, which is an independent, which is a dependent continuum, we have frequency as a semantic. And now let's go to the relations. The relation has component, a physical object that forms a system that is part of a physical entity as component, the CPU, and as quality, a relation between independent continuum, the CPU, it's an independent continuum, and a quality that we get through the frequency. And we have the annotation. And the annotation, as you can see, the preferred label here, and the preferred label for the computer. So we have a description, a complete description for classes, relation, and annotations. So the AFO best practice defined by the Allotrope style guide that you can find on our community website. And the AFO follows best practices for ontology design. It applies top-level ontology, which ensure compatibility, single inheritance that prevents ambiguity, easily modularized, and low computation when you implement reasoning. It's consistent. You can instantiate all the classes, and it's modular and reusable. So AFO altogether, it's a hierarchy of terms. AFO can be serialized using a turtle syntax, and the merge TTL is the AFO suite of ontology. And we see here a partial list of the suite of ontology that comprise the AFO. At the top, the backbone is the Allotrope Foundation taxonomy, the AFT. The AFT aligns with BFO that we have just seen. AFT is a hierarchy of universal, meaning that it's a subclass of the hierarchy is a no relations. It's a taxonomy. It's a tree, just a subclass of. And each term has a unique identifier, mandatory annotations such as preferred label and definition, and term must follow the style guide. So let's look at the AFO. So we take, for example, a display. The display has definition, ID, preferred label, and it's subclass of a device. And now that we go through the BFO tree, it's a material entity, dependent, independent continuum, continuate, and an entity at the top of the tree. At the core, we have the AFO turtle file that contains the core ontology of Allotrope. It adds relations. If you remember, the taxonomy has only the is-a, which is subclass. So the AFO add relations, add logical expression, contain defined classes. We didn't touch defined classes, but practically it's a collection of individual group together. And it imports the taxonomy. So let's look at the type of relationship for linking that the AFO adds to the ontology. So there are object property for linking nodes in graph between classes. So computer is a subtype of a device. Instances and classes. So computer 7 is an instance type of a computer class. And instance to instance, computer 7 as a part display 3. The next one is a display property. So for example, an instance of a serial number 4, has a value of FBC 27600, which is literal. And last, annotation property, linking and reusable for annotation only. It is ignored by a reasoner, so a computer has a preferred label, computer for annotation. So we looked over the many domains of the ontology. We looked on the backbone, on the AFT. We touched the core, the AFO turtle file. We discussed a little bit about the top and mid-level ontology, the BFO, and there are many other domains which are allotrope related, such as calibration, injection, cell counting, and so on. And there are several external domains and other ones that are, for example, ADF related, like data cube, data package, graph, manifest. Altogether, they are all a suite of ontology that are serialized in the merge TTL file. And the AFO sources repository can be found at gitlab.com, allotrope/AFO. And the QA tools and the development tools can be found at Allotrope open source, Allotrope DevOps, again on GitLab, which will be discussed in a moment by the presentation that is going to be given by Karen. Thank you for your attention.
Great, thanks, Amnon.